Rightio. Chapter 12, differentiation. The actual process of differentiation, I would say, is very easy. So hopefully most people know already that to differentiate you multiply by the power and then reduce the power by 1. The thing that most people get wrong, if they're going to get anything wrong with that, is not putting it into this form first, where you have a number, then the variable, and then a power. If it's not in this form, you're going to find it's impossible or very difficult to differentiate. If you've still got it as with square roots or with the x on the bottom or something like that, you're going to make mistakes. So write it in this form first. A number, then the variable, and then a power. And then once you've got it in that form, it's really easy. Multiply the power down and reduce the power by 1. That comes back to chapter 1 of like writing things in index form, so make sure you do that. A couple of other things: increasing and decreasing. Increasing means that the function is going up, so it's got a positive gradient. That just means that the derivative is positive. Decreasing means it's got a negative gradient, so the derivative, the first derivative, is negative. So that's all that means. If it asks you to find the interval on which a function is increasing, just differentiate it and solve the inequality greater than 0, or greater than or equal to 0. Decreasing, less than or equal to 0, but differentiate first and then solve that inequality. Very rarely, not very rarely, but not as often as I see a lot of people doing this, is the second derivative. The only reason you would use the second derivative at this stage is to prove the nature of a stationary point. It's not to find a stationary point, it's to prove that it's a minimum, to prove that it's a maximum. And that does happen occasionally, but I see a lot of people differentiating twice just to find the stationary point, and that's not how that works. So to differentiate a second time, you just do it exactly the same again. So this is the first derivative, you multiply the power down and reduce the power by 1. So it looks complicated, but normally these aren't letters, they're just numbers. So you just times by the power again, reduce the power by 1. Moving on to the intermediate stuff, this is where you're starting to use the derivatives to do things. Firstly, we've got differentiating from first principles. This is just an example, but this is the basic thing you would do to differentiate from first principles. You start off with a function. I didn't say earlier, there's two different ways, depending on if you're given y equals or f of x equals. This will be the first derivative, whereas f prime x is the first derivative if you're giving it as f of x equals. This equation here is in the formula book, but it's just the change in y over the change in x when you increase the x coordinate by a tiny amount called h. But yeah, all you have to do is substitute this formula into this equation. So f of x plus h means you put x plus h where x is. So 3x plus h all squared minus the function itself. Expand this. I've expanded it and times it by 3 just to limit the amount of space, but you can do it in as many steps as you need. Expand it and simplify. 3x squared minus 3x squared disappears, and I've also divided both of these by h. I've done 2 steps in one, but you can get rid of the 3x squared and then divide by h in a separate step. But 6xh divided by h, 6x, 3h squared divided by h, 3h. Now is maybe the weirder part. You've done with all the simplification. You would say as h tends towards 0, so as h gets smaller, the 3h is also going to get smaller. So when h becomes infinitesimally close to 0, or infinitesimally small, then 3h is also basically 0. So it means all you're left with is the 6x part, sorry. Anything with an h in as a product, like you've got 3 times h or 3h squared or whatever you've got, anything with an h that you're multiplying by is going to become 0 and disappear when you do this step, so this limiting step. You should also, it normally tells you to prove something like 3x squared is 6x when you differentiate it. So you'll know if you got it right. Normally, it's quite an easy one to do without first principles, and then first principles is what makes it difficult. Okay, some of the stuff which happens all the time. You've got to know this bit if you're going to get any marks on differentiation, unless it's like a differentiation from first principles or one of the more difficult modelling questions. Almost everything comes from these 4 points down here. So if you're asked to find a tangent, and sometimes you're asked to do more than one of these things in the same question, but if you're asked to find the tangent and you know the x-coordinate, differentiate it. That gets you the gradient function. Sub in the x to find the gradient, and then use y equals mx plus c. If you don't know the y-coordinate, like you're just given the x-coordinate, just put it into the original function. It'll be y equals some function of x. You just put in x, you'll find y. So yeah, differentiate, sub in the x-coordinate to find the gradient, then use the gradient, the x-coordinate and the y-coordinate to complete this and find c. If you're asked to find a normal, very similar, differentiate, find the gradient by doing this, substituting in the x. The only difference is you're going to have to do the negative reciprocal of the gradient before you substitute it in. But you're still just going to substitute in the y-coordinate, the x-coordinate and the gradient. It's the negative reciprocal of what you found from the gradient function. If you're asked to find a stationary point, or a minimum, or a maximum, or to show that a minimum or a maximum or a stationary point exists at a certain point, anything to do with stationary points, minimum or maximum, differentiate it, put it equal to 0, solve it. Okay? Differentiate it and put it equal to 0 for a stationary point, minimum, maximum. If you're asked to prove the nature of a stationary point, there's actually two ways of doing that. My preference would be to differentiate it again, and then if that comes out to be positive when you put in the x-coordinate of the stationary point, that's a minimum. If it comes out to be negative when you put in the x-coordinate of the stationary point, it's a maximum. Okay? There is another way to do it, where you look at the gradient just before the x-coordinate of the turning point and just after the x-coordinate. So say your x-coordinate was 2, you put in 1.99 and 2.01 into the gradient function and see what happens to the gradient. So if the gradient is negative and then 0 and then positive, that's a minimum. If the gradient's positive, then 0, then negative, that's a maximum. And if it goes positive, 0, positive, or negative, 0, negative, that's called a point of inflection. So that only happens occasionally when you've got positive, 0, positive, like it comes out positive before and after the turning point. Not turning point, stationary point. Okay, advanced stuff. Modelling tends to trip people up because the first question is almost always just some algebra. It's just some algebra from GCSE. Normally it's to do with either a two-dimensional shape or a three-dimensional shape. And they tell you some stuff about the shape, and they tell you, say, like they give you the perimeter of the 2D shape, or they give you the area of the 2D shape, or the surface area of a 3D shape, or the volume. They give you one piece of information, and then they just say, show that this is true, and it doesn't involve any differentiation at all. So for example, in this case, this is just a shape. It's just two rectangles and a quadrant. Okay, so you work out the perimeter and the area. You just write them in terms of x and y, GCSE style. Okay, the next step is you look at the piece of information that they've given you. So they might say the area of this is 100 or whatever. And what you do is you just put this equal to 100. So you've got an equation that says 100 equals this, x and y, two variables. And then up here you've got a perimeter which is also x and y, two variables. What you want to do, they'll tell you what they want it to look like in the question. You want to get rid of one of the variables, okay, so that you can differentiate it. Normally that means either making x or y the subject and substituting it into the other equation. You want to make the one where you've got the number the subject. So you want to change, might be this one, you want to make x the subject. So you just you've got 100, put that on that side, put the 2x minus y on the other side or whatever. Make x a subject and then substitute it in here for x. Okay, so then you've only got one variable. If you make something the subject and then substitute it into the other one, it gets rid of that variable. If you make x a subject and substitute it into the other one, it makes that the subject. You're solving them simultaneously, essentially, but where one of them isn't, you haven't got the number, so you can't actually solve it. But it's the same first step, right? Substituting in one of the variables to get rid of it. That's the first step. And then, even if you can't get to the end of that, it doesn't matter, because the actual differentiation part is normally find the maximum or find the minimum. Okay, that's when the actual differentiation starts. And normally it's quite easy because the difficult part is the model. But make it in this form, differentiate it, put it equal to 0 because it's a minimum or a maximum, solve it for x or y or whatever it is, and then find the maximum. So if they ask you to find the maximum perimeter, given that the area is 100, or find the minimum, actually, the minimum perimeter would make more sense, given that the area is 100, differentiate it, put it equal to 0, find the turning point. Okay, you'll get a value for y or for x, and then substitute that back into the equation. It's normally the equation that's in the question, like part A, where they say show that the perimeter is equal to this. I think I've almost stolen this exactly from an old exam question, but they're very similar. There's also ones to do with volume and area, like volume and surface area. It's the same thing. Write the two equations, they'll give you the number for one of them, rearrange that to get one of the variables as the subject and substitute it into the other one. The other things that come up, very short one. If it ever says rate of change of something with respect to something else, that's because it wants you to differentiate it. So it could be rate of change of perimeter with respect to x. You just differentiate it. It might be different variables. It's not going to normally be y and x. It's normally be like p and x or p and whatever's in the question. But you just differentiate one with respect to the other. So if you're looking for the rate of change of p, it's going to be dp over d whatever the other x. If it's x, like this top one, we make if we make x the subject of this and substitute in there, we'll have p in terms of y. So we could do dp by dy. But it's the same process as this, just instead of y and x, it's d and y. Okay? So just my point is rate of change, differentiate it. And I think that's all of differentiation. Lots of practice, because differentiation is one of the major topics in year 13. You want to get it completely solid from year 12 before you go on to year 13, because it's where a lot of the marks come from in the A level. So that's it. Thank you. Enjoy.